Good morning students and welcome to our YouTube channel Eng.Med Remote and School. In the previous video we are just going through the chapter number 13, that was electric current and its effect. Okay students, here we have just completed in the previous video, that was working of electric fuse, magnetic effect of the electric current, electromagnet. Okay, now first of all I have given you homework of the let's answer. I am just giving or writing the answers on the board. You just verify your answer. That is, let's answer which is on page number 163. Let's answer first one. That is, a dash is drawing of an electrical circuit in which the various components of the circuit are represented by the standard symbol. Okay, so in that it will be circuit diagram. First one, it will be circuit diagram. Second one, that is, electrical appliances that produce heat containing tightly wounded coils are called dash, that is, filaments or heating elements. Then second answer, it will be heating elements. Heating elements. Third one, an electric dash prevents a large amount of electric current from flowing through any appliances by cutting off the supply of the electric current, that is, electrical fuse is used. Third one, that is fuse. Okay. Fourth one, that is, materials used in fuse wires have dash melting points. Materials used in fuse wire that are having low melting points. Fourth one, low melting point. So please write down the answer, students. Okay students, have you written down the answers? Now moving forward. In previous video we have seen the magnetic effect of the current. In that we have seen the electromagnet. What is electromagnet? There is a bar of iron. When we just wound a wire, okay, then a magnetic field is produced by it, so it is known as an electromagnet. Okay students, here I am just reading it again. That is, electricity and magnetism are closely related. When an electric current passes through the wire, it produces a magnetic effect. Then electromagnet, the magnetic effect which you observed in the above activity can be increased if we make a tightly wounded coil with the current carrying wire. This effect becomes even stronger if the wire is wounded around an iron piece called the core. Such an arrangement, a piece of soft iron coiled with an insulated wire wounded around it that acts like a magnet when an electric current flows through it, is called an electromagnet. Okay, it is known as the electromagnet. Then after here we have seen the activity, and here we have reached to the properties of electromagnet. Properties of electromagnet. Let us see. Properties of electromagnet. Properties of electromagnet. The first one, that is, electromagnet acts like a magnet only when the current flows through the wire. Here, the first one wounded around it, it loses its magnetic property when the current stop flowing. So the first, that is, electromagnet and electromagnet and electromagnet acts like a magnet only when current flowing through the wire wound around it. Okay. Second one, that is, the magnetic strength of the electromagnet depends upon the numbers of turn of the wire wound. Means the magnetic strength will be depend upon the how many wire much round we have just wound the wire. The magnetic strength of the electromagnet depends on the number of turns of the wire wound. Okay, around its core, okay. And the third one, that is, the magnetic strength of an electromagnet also depends upon the amount of the electric current flowing in the wire. So the another point, that is, the magnetic strength of an electromagnet depends on the amount of electric current flowing in the wire Okay. First property, that is, an electromagnet acts like a magnet only when current flowing through the wire wound around it. Then after, it will, when the current is stopped, then it will not work as the magnet. Second one, the magnetic strength of an electromagnet depends on the number of turns of the wire wound around its core. Means how many times the wire is wounded, the magnetic strength will depend upon that. And the third one, that is the magnetic strength of an electromagnet, also depends on the amount of electric current flowing through the wire. Okay, it will also depend upon the how much current is passing through the wire. So these are the three properties of electromagnet. Please, if you want to just underline, you can underline. And then coming towards the uses of electromagnets. So following are some uses of electromagnets. The first one, that is electromagnets are used in many electrical appliances that have moving parts such as roaster, washing machine, fans and mixture grinder. Electromagnets are also present in the MRI machines, uses in hospital and medical diagnostic centers. Electromagnets are used in cranes to pick up car in the scrapyard and in the garbage dump to separate iron from the rest of the garbage. Then after, an electromagnet is a very important part of the old fashioned electric bell. So these are the uses of electromagnet. It is used, electromagnet is used in the washing machines, then in the toaster machines and that all things. Okay, but the electromagnet was used in the electric bell in the olden days. Okay, and these were the properties. Now just moving towards our new topic, that is the electric bell, and which is the last topic, I think. So here, an electric bell. What is it? An electric bell is battery operated device consisting of a U-shaped electromagnet connected to a battery and a switch. The base of U-shaped magnet is also connected to a small metallic ball, which is generally called the hammer. Below shown how an electric bell works. Here you can see an electric bell is given. So what happens? See, first step, when you push the switch of the bell, an electric current flows to the electromagnet. When you just switch on, or you just put the switch on, then what happens? The current goes to the electromagnet. The second step, that is, the electromagnet attracts the soft iron strip. The hammer attached to the strip that hits the gong, causing a ring. What happens when you just switch on the first step? Then the electromagnet just start working, and the hammer will just make the sound. Okay, the hammer which is given, that will make the sound. And the third step, that is, when the soft iron strip gets attracted to the electromagnet, it no longer touches the screw. So this turns off the electromagnet and it can no longer attract the soft iron strip. The soft iron strip return to its initial position touching the screw. This result in the circuit being complete and current flowing again. Okay, here step 1 to 3 repeat in quick succession as long as the switch is on. This is how we hear a continuous ring of a bell. Nowadays, electric buzzers and musical electric bells are used. They work on a different principle than the one described above. Here, electric bell. First of all, we know that how the electric bell works. The first step, when you just switch on the electric bell, then what happens? The current will flow through the circuit. As the current will flow, the electromagnet get active. Why? Because the current is given to it, to the coil. Then after, what happens? The electromagnet will start active, and the hammer which is of iron will just do like this. Then what will happen? The bell will ring. Okay, but it will be continuous up to when you just have on the switch. After that, when you just take it off the switch, then it will not happen. Okay students, here we have just completed the chapter. So what we have seen in this video, that is first of all properties of the electromagnet. So the first property was what? You repeat by your own first of all. I can't listen, but you repeat by your own first. The first one, that was, an electromagnet acts like magnet when only when the electric current is flowing through the wire. The electromagnet will only act like a magnet when the electric current is flowing through the wire. The second one, the magnetic strength of the electromagnet will depend upon the number of the turns of the wire wounded to the bar. Okay, the magnetic strength will depend upon it. And the another one, the magnetic strength will also depend upon the electric current flowing through the wire. So it will also depend upon the how much current is flowing through the wire. And the another one, here we have just completed the three properties of the electromagnet, and then after we have seen the uses of it. So which are the uses? That are, electromagnets are used in many electrical appliances that have moving parts such as toasters, washing machines, fans and mixture grinder. So it is in the toaster, washing machine and many other devices the electromagnet is used, where it is moving thing is there. Then after, electromagnets are also present in MRI machines used in hospitals and medical diagnosis centers. It is also, electromagnet is used in the MRI machines. Okay. Then after, electromagnets are used in cranes to pick up cars, in scrap and in garbage dumps to separate iron from the rest of the garbage. So it is also used in the crane for the pickup of the cars, and also in the scrap yard or garbage yard. So the electric iron things can be separated. Okay, iron things can be separated, so it is used. And the fourth one, that is, an electromagnet is very important part of the old fashioned electric bell. So it was also used in the electric bell, but nowadays this is not used in nowadays modern electric bells. It just work upon the different system. And then after, we have seen the electric bell, that is, an electric bell is a battery upon the device consists of a U-shaped electromagnet containing the battery and a switch. The base of the U-shaped electromagnet is connected to a small metallic ball which is generally called the hammer. Figure 13.6 below shows how an electric bell works. Here you can see how it is worked. First step, that is, when you push the switch on the bell and electric current flows to the electromagnet acts the soft iron strip. The hammer attached to the strip then hits the gong, causing a ring. When the soft iron strip gets attracted to the electromagnet, it no longer touches the screw, and hence the circuit is broken. This turns off the electromagnet and it cannot longer attract the soft iron strip. The soft iron strip returns to its initial position, touching the screw. This results in the electric circuit becomes complete and current flowing again. Okay, so this will repeat 1 to 3 step will be repeated up till when you just have on the switch, and then after it will be disconnected. So here we have just complete the chapter. Here it is given the let's answer. First of all, writing the answers of it, and then after giving homework. So let's answer. That is true or false. An electric wire heats up when an electric current passing through it? Yes, it is true. First one, that is true. Second one, two or more cells joined together form an electromagnet. No, that is false. Third one, an electric toaster works on the heating effect of the current. Yes, that is true. Fourth one, an electric fuse wire is made of a material of very high melting point. No, it is made up of very low melting point. Fourth one, that is false. Fifth one, an electromagnet retains its magnetic effect even when the electric current in it is switched off. That is fifth one, that is false. Okay, so in your homework what you just do is find out the answers of exercise. Okay students, we will meet in the next video. Bye students.